Hey, what's up, y'all? Today we're going to be using all the JARViE PLM demo boards in order to mock up a power line network so that we can introduce to you the newest product addition, which is the JARViE PLM HAT. The HAT stacks on top of a Raspberry Pi in order to create a PLM IoT, or Internet of Things gateway. The gateway can connect to the internet via an Ethernet connection. You can also connect a keyboard and a mouse up to it and a monitor so that you can develop code directly on the Raspberry Pi single board computer. Notice that the power that's going into the IoT gateway is coming directly from the 120 volts AC power line that it's going to communicate over. You can also supply up to 240 volts of input in order to power the Internet of Things gateway as well. And that goes for all the JARViE demo boards that accept VAC power and then convert that power into DC in order to power some of the low power DC peripherals on board. So the Shield and the only JARViE device with the embedded microcontroller, the PLM SHAR, does the same thing. So we have device 0, which is going to be the JARViE demo board. Device 1 is going to be the JARViE Shield, and device 2 is going to be the PLM SHAR. So each firmware of the device has an embedded unique identifier. So it knows which device the gateway intends to talk to. So the gateway will send a preamble, or essentially a header identifier device, before it sends a command on the bus, and then only the device will respond to that command. So the particular demo I'm about to run is going to go through and identify each device on the bus. When the device is identified, the LED of that particular device is going to blink. Notice when the device that there will not be two devices with their LEDs blinking at the same time. What we're going to do is we're going to SSH into the Internet of Things gateway. We've developed the script in Python. It will send serial commands to the modem on the HAT. The HAT will then forward the commands using ASC modulation on the bus, so then it can communicate to all other devices. So let's go ahead and run the script. You can see that the LED on device 0 is blinking, meaning it's identified. Then we'll have device 1. There you go. Notice device 0's LED is not blinking. And then we're going to get device 2. There we go. So notice that no two devices' LEDs were blinking at the same time, meaning that it could distinguish between the commands that the gateway was sending, and the gateway was able to communicate to each device separately by sending a unique identifier. So this helps if you have 3 different devices on the bus, one that controls lighting, one that does load shedding, say of a large appliance. So we want to make sure we remove large loads when your house is on there to backup energy storage, like a Tesla Powerwall. And then let's say the 3rd device helps connect or remove a bad solar panel from a local solar panel grid that you created at your home. These are just some examples that you can do with the Powerline network. I think the biggest thing is to have a powerful controller. That's what the PLM HAT stacked on top of the RPI allows you to do, essentially creating an internet gateway that you can use to host a web server with the diagnostics of your PLM network, or control your PLM network from over the internet, etc., etc. Thank you so much for watching.